Welcome to Mr. Gitz's Flipped Classroom. We're going to be taking a look at some math problems here today. The question says, a bike path is 4/5 of a kilometer in length. Marco bikes 1/3 of the path before stopping for water. How much of a kilometer did Marco bike before stopping? Now with this, the bike path, the whole part of it is going to be 4/5. That's how big the path is. And he's going 1/3 of it. So our answer, just looking at this, is going to be less than 4/5. And what we're going to do is multiply. If you multiply a number by a fraction less than 1, your answer is going to be smaller. So let's check this out here. So we have 4/5. And then I said we're going to multiply it by 1/3. And that's going to be 4/15. 4/15, or that would actually go there. 4/15 would go down there. So that's going to be our answer, and then this right here is going to be the equation. Now we do have this visual fraction model here, and I want to show you how that works, because this is another way to do this problem. What we have here is we say 4/5. Now, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 15 total. We got 15 total here. Now let's do that 4/5 first. To do that, I'm going to say, all right, so this is going to be, we're going to take 4 out of the 5. So 4 out of the 5, I'm shading that way for 4/5. Now look at this, 1/3. 1, 2, 3. I'm going to shade the other way on 1 out of 3 here. So I have 1 out of 1, 2, 3 shaded. The overlap. This is overlap, this is overlap, this is overlap, this is overlap. The overlap is going to be what we'll see in our numerator, which is 4. 1, 2, 3, 4 out of, there's 15 total. 5 times 3 is 15. Two ways to look at that problem right there. Very nice. Now here's another one. Dividing rational numbers. Exit ticket. It says dividing right here. Camila was helping at the triple chocolate cake booth and wants to know how many cakes were sold. Use the information provided to determine how many triple chocolate cakes were sold at the bake sale. Right here, the cakes are $17.25 each, and the total earned $86.25. It says it's going to be dividing. One way to set this up is to say, let's do 86. How many times does 17 go into 86? I can see I already wrote that in a way where I have no room to solve it. Let's go ahead and put it up here. 1786. Well, does it go 3 times? Well, let's go ahead and count by 17s. Check this out. 17 times. So 1 times 17 is 17. 2 times 17 is 34. 3 times 17 is, you can just add those together, 51. 4 times 17, 68. 5 times 17, so I can add 17 to that to get to 85. And then what about 17 times 6? 2, 4 for up there, 10. 6 times 17 is equal to 102. That's going to be too far. I went too far. Right here we see if there is 5 is going to equal a number approximately 86. Now what you could do is you could go ahead and divide this and keep those cents in there. But what I did was, and what I've been teaching students in class, is the power of estimation. Right? So doing an estimate, because we can only have a whole number of cakes. So what if we say, let's take this 86.25, 17.25. Now this is going to look interesting here, right? So we know it was 5. So if we were to just multiply it like this, because it's easier to see, times 5. 5, 2 for up there. 2, 1 for up there. 5 times 7, 7. 5 times 7 is going to be 35. 36, 6, and I said 36, 3 for up there. 5 times 1 is 5 plus 3 is 8 is going to be that check. Always want to try to solve problems. Always want to try to solve problems a couple different ways there. Sorry, I had that off the page there. Oh my gosh. Got to keep experimenting with these different cameras and ways of showing math problems. I want to show something else that we did in class. Students had an opportunity to work with more of these area diagrams. So some people call this the multiplication box method. Sometimes it's called an area method. Now, this was something that students were working on in groups of 4 in class. And what we have here is expression. It's getting cut off at the top here. What we have here is expression, model, and then we have product. Now, what I want to do with this is turn these all up so you guys can see them here. And the students were doing a card sorting through some cards here. Let's see what this even looks like here. So let's take this one first. So this one we have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1, 2, 3, 4, 5. 8 times 5 is 40. Okay, well, not quite sure which one of these we're going to be using next year. I see a 40 right there. Very nice. Let's see what happens here. See what we can see. Now, if we look across here, there's going to be 1, 2, 3, 4 out of 8 shaded. Check that out. That's a 4 out of 8 right there. And you see 4 out of 8. I like that. But it also could be a half, right? 4 out of 8 is also a half, so it could be that one there. Let's keep looking here and see what we have. Okay, we got the 4 out of 8. Now let's count these. 1, 2, 3, 4, 5. 2 out of 5 are shaded right here. 2 out of 5. Well, heck. 4 out of 8, got that. 2 out of 5. Let's look at the overlap area. The overlap area is 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 40. So that's the one that's going to fit in right there. Very nice. Let's take a look at another example here. Same method, right? So what's the total? Let's do the total first. 1, 2, 3, 1, 2, 3, 4. 12. Okay. But it looks like we have 1 out of 1. Oh, sorry. We have 1 out of 1, 2, 3, 4. 1 out of 4. Do I have a 1 out of 4 somewhere? Yes, I have a 1 out of 4 right here. Do I have another 1 out of 4? Let me look. I don't see another 1 out of 4. That's the only one I have. Okay, so I got the 1 out of 4. 1, 2, 3, 4. And now let's look at the other one. 1 out of 3. 1, 2, 3. I have 1 out of 3. So that looks good. My answer is going to be, what's double shaded? Double shaded goes in the numerator. Numerator's at the top. Denominator's at the bottom. D down, denominator. N, numerator. Numerator is the top. Looks like we have a nice little 1 out of 12 hanging out here. Very nice. And let's take a look at one more example before we go for this time. Okay, what is happening here? Don't know if we need these pieces. Don't know if I like these pieces, but let us see what's going to happen here. So I have 1, 2, 1 out of 2. So this is going to be a half. Here we go. Got a half right here. What else do we have? I have 1, 2, 3, 4, 5, 6. I have 5 out of 6. 1 half, 5 out of 6. Very nice. If you go to multiply them, 5 times 1 is 5. 6 times 2 is 12. So that looks like this is going to be a 5 out of 12. Or count them here is another way. 1, 2, 3, 4, 5 are double shaded out of 12. And then it's going to be right there. 5 out of 12. Thanks for hanging out with me in Mr. Getz's flipped classroom.